To test the validity of the data, we must check for both convergent validity and discriminant validity. Convergent validity refers to the positive correlations of measures within the same constructs. It means that the items of one variable must be positively correlated to each other. We're going to test composite reliability and average variance extracted to test convergent validity. Discriminant validity refers to the distinction of the items of one construct from other constructs. And we will use Fornell and Larcker condition to test discriminant validity. Here, these are the factor loadings of my variables. This is my dependent variable and these are my independent variables. And if you haven't seen my previous video on factor analysis, please do. If you watch that, you will see that how did I get to these numbers. These are the factor loadings of my items through the factor analysis which I did there. And these are exactly the numbers which I got from final rotated component table that we reached at the end of the video. So I just copy paste the numbers here, and now I'm going to explain the test that we have to do in order to measure, in order to confirm convergent validity and discriminant validity. So first thing that we have to do is that we have to calculate the power of 2 of factor loadings of each construct one by one. So we put the factor loadings to the power of 2. So here's the formula. So each factor loadings one by one we put to the power of 2, and then we calculate the sum. So the sum of the power of 2 of the factor loadings of each construct. And then we repeat the procedure for each of the variables separately. After that, we will calculate 1 minus power of 2. So here 1 minus power of 2, and then we calculate the sum of those. So here's the sum of these, and for example here sum of these items for this construct, here sum of this item for this contract, and so on. After that, we want to calculate average variance extracted. How would we do that? We calculate the average of sum of the average of the sum of power of 2 for each construct. So here, since we have 3 items, we divide the sum by 3. For the next construct, since we have 4 items, we divide the sum by 4. And so on. Here we have 2 items, so we divide the sum by 2. Here's how we got the average. And then if the average values are above the threshold of 0.5, then this is confirmed. And as you can see, all the average values are above 0.5, so we're fine. Next, we have to calculate the composite reliability of each construct. The formula I will show you. So here you can see the formula. Here we put the sum of factor loadings to the power of 2 over same value, sum of factor loadings to the power of 2 plus sum of 1 minus power of 2 of the factor loadings. Don't forget the parentheses. And this is how that we calculate composite reliability for each construct one by one. And if the value of the composite reliability of each construct is above the threshold of 0.7, then this is fine. If these two conditions are set, then we could say that we have convergent validity of the data. In order to calculate the discriminant validity, we have to first calculate the square root of the average variance extracted. So this is the formula for that. We just calculate the square root, and then we have to replace it in the correlation table of this construct. So I have to open my SPSS file, and then I would go to the analyze, and then to the correlate, and now I choose my constructs from here. I can show you how did I choose them. So these are my constructs that I want to check for the discriminant validity, and then OK. So now I have a Pearson correlation. I just simply copy it to my file here. You can delete the rows that you don't need, so it would be more simple to look at. And if you notice, these values are mirrored, so you can either look at these rows or these columns. It's the same, so I can just delete these numbers, so the table would be simpler. So now I can see that okay, so so food quality and food quality is the same construct, so it's 1. But service quality and food quality are correlated, and all of them, as you can see, are this correlation is significant. But the thing is, I have to replace this square root with these numbers, with this one number 1 here. So for example, here is for the value for money. I replace it here, value for money. Here is for service quality. I replace it for service quality. Here is for purchase intention. And I need food quality. Decrease. I want to round the numbers. So now the results shows that the square root of the average of each construct is greater than its highest correlation with any other construct. So as you can see, this value here is higher than these values, this value is higher than this, and this value higher than this. So we can conclude that the discriminant validity is also satisfied. So overall, convergent validity and discriminant validity were satisfied. If you like my tutorials, please use the bottom right corner to subscribe to my channel and watch my other videos.